students, good morning! In this tutorial, we will be discussing multiplication of polynomials, particularly binomial times a binomial using the F.O.I.L method. Now, here are concepts you need to recall. Don't worry, if ever nakalimutan nyo na, we'll try to explain them as we go along. Let's try to recall first the distributive property of multiplication over addition, a topic we know from elementary. Let's say we're given three numbers, A, B, and C, in this arithmetic question. Order of operations, or the GEM-DAS rule, or PEM-DAS rule for some, would dictate that we should combine B and C first because of the grouping symbols here. However, the distributive property would tell us another way of doing this. We can simply distribute A by multiplying A with B and then A with C, meaning A times B is AB. Then copy the plus sign and then A times C is AC. So the answer is AB plus AC. This property is of course applicable also if the number to be distributed is from the right side instead, as quickly shown here. And of course, we can also recall that this is applicable not only for addition, but also for subtraction, replacing plus with the minus sign, again, as quickly shown here. Now, we can apply the distributive property to multiplying binomials. We have a general case here where the binomial x plus y is multiplied to the binomial a plus b. We can't immediately use distribution here because there is no one number to be distributed. So what we can do is to think of the quantity a plus b, this one, as 1 factor m. Now, let's try to replace this whole group as m. Doing that, we can rewrite x plus y times m. Now, this looks familiar. We can now apply distribution. So we have x times m is xm plus y times m is ym. But there's really no such thing as m. That value was just assumed to be able to use distribution. So let's replace m with the original value a plus b, like so. So this becomes x times the quantity a plus b plus y times the quantity a plus b. Notice again, this looks familiar. We can distribute both x and y to these a plus b groups. So doing this, we have x times a equals xa, x times b equals xb, y times a equals ya, y times b equals yb. Hence, we have the final product xa plus xb plus ya plus yb. I know, this looks like complicated work. Don't worry, there's a much easier way. We can look at these two binomials as each having a first and last term. If we observe, the final answer here can easily be solved by looking at it another way. Let me explain this. xa can be derived by multiplying the first terms, these two, therefore xa. xb can be derived by multiplying the outer terms, therefore xb. ya can be derived by multiplying the inner terms, so we have ya. And finally, yb can be derived by multiplying the last terms, therefore yb. So, an easier way of multiplying binomials is by simply remembering that the product is just the combined products of the first, outer, inner, and last terms, hence the F.O.I.L method. Easier, right? We're now ready for some exercises. What if we're trying to multiply these binomials? Since we're new at this, we write F, O, I, and L as guides. So we multiply the first terms first, these two, set it up, x times x. Then we write plus. Then we multiply the outer terms next, set it up, x times 7. Again, we write plus. Then we multiply the inner terms, 3 times x. Again, we write plus. And finally, the last terms, 3 times 7. Of course, if you're a faster multiplier, you can skip setting up in this line and immediately write the products. X squared plus 7x plus 3x and plus 21. Now we need to combine like terms. Usually, when multiplying binomials, the products of the outer and inner terms can be combined. So, we simplify everything as x squared plus the sum of the outer and inner, 10x plus 21. So that is the answer. Here's example number 2. We are multiplying x plus 2 and x minus 5. This one's different from the previous example since we now have a minus sign here instead of having plus in both binomials. You might want to be more careful here because this is where some students commit mistakes. At first, we'll try to solve it using a longer but more careful way, then do it faster later. Note that minus 5 here is the same as writing plus negative 5. As guide, we can still write F, O, I, and L. FOIL method. We can skip setting up the terms and immediately multiply mentally. Okay, first terms. X times x here is x squared plus. You can always use plus first if you want to be more careful. Then outer terms, x times negative 5 is negative 5x. Plus, again, always use plus first. Inner terms, 2 times x here is 2x. Plus, last terms, 2 times negative 5 is negative 10. As usual, the outer and inner terms are like terms. So combining, we have x squared plus negative 5x plus 2x is negative 3x plus negative 10. But plus negative here is not simple enough. Finally, let's simplify it further. X squared plus negative becomes minus 3x, and also this becomes minus 10, giving us this final answer. Now that took a little longer than we would like. Here's a faster way of doing it. Just be more careful lang. Solving the same question and again as guide, we can still write F, O, I, and L. Then we should remember that the last terms here, these two, are positive 2 and negative 5. We should include their signs. So, the first terms, we have x times x is x squared. Then outer terms, x times negative 5 is negative 5x or minus 5x. They're the same. Inner terms, 2 times x is positive 2x or the same as plus 2x. The last terms, 2 times negative 5 is negative 10 or minus 10. Combining these like terms, these two, we have x squared, negative 5x plus 2x is negative or minus 3x. Then finally minus 10, resulting the same answer but faster this time. Here's example number 3. We are multiplying the binomials x plus 6 and 5 minus 3x. So, we write F, O, I, and L. Then just like in the previous example, the last terms here are positive 6 and negative 3x. Include their signs. So the first terms, x times 5 is 5x. Then outer terms, x times negative 3x is negative 3x squared or minus 3x squared. They're the same. Inner terms, positive 6 times 5 here is positive 30 or plus 30. The last terms, positive 6 times negative 3x is negative 18x or minus 18x. Now, observe that this case is unusual. We cannot combine the outer and inner here katulad ng ibang previous examples. Instead, these are the like terms, which is still okay. So we combine like terms at the same time, arrange the terms in decreasing order of degree. So this term should come first. We can now have negative 3x squared. Note that the sign comes with the term when we're arranging. Then 5x minus 18x is negative or minus 13x. And finally, plus 30. This is the answer. While our answer is correct, let's try to investigate why we went through a slightly different method. Looking at the second binomial here, we notice that it's not arranged in descending order of degree. So, if you have noticed this earlier, we could have arranged it correctly, negative 3x plus 5 instead, like so, being able to combine both the outer and inner as usual, and get the same answer as quickly shown here. Here's our last example. We may encounter binomials with more than one variable like this. Don't worry, as long as we follow the rules of exponents, we should be able to get the product of seemingly more complicated binomials. So as a guide, let's underline our last terms here, and then write F.O.I.L. First terms, 3a times a is 3a squared. Now, for the outer terms, you might want to be careful and do it step by step. Multiply the signs first. Positive times negative is negative. Then, the numerical coefficients, 3 times 2 is 6. Then the variables, a times b is ab. Hence, negative or minus 6ab. Inner terms, positive times positive is positive. Then the variables b times a is ab. Hence, plus ab. Last terms, positive times negative is negative. Then the numerical coefficients, we have 1 here, times 2 is 2. Then the variables b times b is b squared. Hence, negative or minus 2b squared. So, combining these two like terms here, outer and inner, we have 3a squared, negative 6ab plus ab is negative or minus 5ab, and finally, minus 2b squared. Hence, the final answer. You are now given a chance to answer some exercises. You can pause this video to do this on your own. Don't worry, the answers will be shown later. So, you can try this now and pause this video. Kaya yan, go! Here are the answers so you can check. Please don't forget to like and subscribe. Happy solving!